Let's look at some past paper questions on the proving of quads. Okay, so this is a question from last year's test for term 3. And they gave you this question where there's quite a bit going on. So unfortunately now, the copy that I had of the test that I scanned in, unfortunately already had me highlighting the quads there that we were working with. But yeah, so actually all that was given to you is, I believe that this line is equal to that line. That was all that was given to you. So let's quickly check here. A, B, C, D. So this is this one that I made this purpley pinky color is a parallelogram. Okay, wonderful. That should be making certain things go pop into your brain by different properties, right? Then they tell you BD and AC intersect at O. Okay, we should know that's a midpoint, right? It's the midpoint of this line as well as that line. Then AF is equal to OD. Yeah, that's the part they gave you, as well as CO. Okay, so that also gave you CO is equal to FB. Okay, so those were the informations they gave you, and that just says a bit more. So already now, from this being a parallelogram, you should be thinking of, okay, so they specifically gave you, you see, those information for a reason, but you should know that this and this is equal, right? And similarly, those two are equal, and we should know that is because the diagonals of a palm bisect one another, right? And they told you it's a palm, so we know this to be true. Now, this one that I made, this greenish color, they're asking you to prove it is a parallelogram. So, now ready. Just from what we added here, okay, do you see they told you those are equal, but we know those two are equal. Okay, that makes them equal. Similarly, that was told to us that those two are equal. We know these are equal, meaning those are equal. So you should be able to see from this that yes, you worked with your diagonals here, but they made the opposite sides of this green one a quad. Okay. Oh, sorry, made it a parallelogram. So now how to write that down. Let's start with 2.2.1. We're going to prove that BOAF is a parallelogram. It's 4 marks. Okay, so we're going to start off by saying those two are equal, but we know those two are. So we're going to say that AO and OC are equal because they are the diagonals of a palm. Similarly, we know that OD is equal to OB. Same reason, diagonals of a palm. Now, but the part that we were given, right? So because we were told that this one and this one is equal, okay, so it's like kind of like, but they told us that OC is equal to FB, so therefore we have, okay, that's the same side, so AO is equal to FB. Similarly, with these ones, they told us that AF and OD are equal. Okay, therefore, OD and OD, so that would make OB equal to AF. So now because of those two being equal and those two being equal, we can say that BOAF is a palm because the opposite sides of the quad they gave you are equal. We are going to go say those two are equal and those two are equal because of the diagonals of a palm. Then you do some abstract maths. You look at what they gave you and what that means. You look at what they gave you and what that means, right? And then because those two are equal and those two are equal, they are the opposite sides of, we only know it's a quad. We can see it's 4 sides, so we know it's a quad. So because the opposite sides of that quad is equal, that makes it a palm. I'm going to go and write it nicely like this. Okay. Now, in this next question, this one is actually a little bit more tricky than the first one. So they're asking us to prove that AD and EA are equal. Okay. So far we've worked with this purplish one, okay? And we know this is a parallelogram, so we know that those two sides are equal, but we also know that those two sides are parallel. Okay, do you kind of see that also means that the AE part is also parallel to here if we now cut it on this line and just look at this portion at EACB. Similarly, we prove that this green one is a palm. Okay, you kind of see where I'm going. So we know this side and this side is parallel. Okay, so now we have that these two sides are parallel, but also that those two sides are parallel, meaning this is a parallelogram. Okay, and that's how you are going to prove that those two are equal with using this BC as being the opposite side of both of them in their respective palms. Okay. Now that was a lot of words. Let's go write it down. So firstly, we have that AD is parallel to BC, opposite sides of palm. And similarly, we have FB is parallel to AO, same reason. Okay, we don't have to add the parallel here because we're not proving parallel. The reason why they are parallel is because they are the opposite sides of parallelogram. Then, because of this, we can actually deduce, because this is a straight line, that EA is actually the one that's parallel to BC. And similarly, that the whole of EB is parallel to AC. Okay, because the portions are, they're on straight lines, then the whole line is. Then you have that EACB is a palm, and it's because the opposite sides of the quad, on this case, parallel, not equal. Now, because of this, we can say AD is equal to BC, but also EA is equal to BC. Okay, and in both these cases, it's the same here, opposite sides of palm. And then because, okay, BC is the same line, that means that AD is equal to EA. So this was the second one. I just forgot to write there 2.2.2. Okay, so the idea here was, and what made it tricky is we didn't know straight from the question that we had to prove a parallelogram. But you had to. You had to prove that this one is a parallelogram by using that AD being parallel to BC actually means the whole line is, and therefore also the section here. Similarly, in the green one, those two being parallel means actually the whole line, and the whole line is equal, is actually parallel, sorry. And then the squad is actually a parallelogram, which is why, because those two are equal and those two are equal, then those two are